Hello and welcome to season 3 of our series Back to Basics. This season 3 is all about sustainability. Sustainability is a vast topic. Therefore, we have decided to do 14 episodes in this series. The first episode will be all about the Earth, the planet Earth. We need to start from where we live. The other episodes are listed next to me here, and we will come back to them over the course of the series. Let's start the planet Earth. To begin our journey of sustainability, we need to provide context and explanations about our planet and its limits. Yes, the planet has some limits. But before we can explain the limits, we need to explain the birth of the planet. Our aim is not to provide a full history of the universe and the creation of the planet, but just to give enough background information to better understand the next chapters. Are you ready? At the start was the Big Bang, 13.8 billion years ago. Let's pass the intermediate stages and arrive at the birth of our Sun. The Sun is a star which is 4.6 billion years old. Yeah, we jumped forward more than 9 billion years. And the Sun was created from a cloud of dust and gases. The cloud's own gravity has increased its density in the center to such a point that a thermonuclear reaction started and it became the Sun. The rest of the dust and the gases have aggregated in disk, which itself has aggregated into rings around the Sun and finally into planets and comets. The proto-Earth, so the Earth before the Earth, grew until its interior was hard enough to melt the heavy metals, such as iron and others. Being the densest, they created the metallic core of the planet, with lighter elements creating a mantle around it and setting up the formation of the Earth's magnetic field. This is the origin of the Earth's layered structure, as we will see later on. So, early in Earth history, a collision with a protoplanet expulsed mantle and core and created the Moon. So in short, the proto-Earth is a sphere, very dense in its center, less dense on the outside, and a moon made from it. So what does the Earth look like now? It is a sphere of about 13,000 kilometers or 8,000 miles in diameter. A little flattened at the pole and bulging around the equator. Its mass is approximately 6 times 10^24 kilogram or 1.3 10^25 pounds. Its surface is 510 million square kilometers or 197 million square miles. Part of its surface is covered by water in a liquid form because of the temperatures prevailing on the surface. This part is 72%. On the emerged areas, soils form the upper layer of the land and are the substrate of vegetal life, and therefore agriculture. Earth is surrounded by an atmosphere composed of gases. The atmosphere composition is the result of an original composition altered by vegetal life, which transform carbon dioxide into oxygen and have depleted the atmosphere of most of its carbon dioxide. Human activities have a high impact on the atmosphere composition, but we will see this later. Overall, the planet is composed mostly of iron, 32%, oxygen, 30%, silicon, 15%, magnesium, 13%, sulfur, 3%, nickel, 2%, calcium, 1.5%, and aluminum, 1.4%, with the remaining 1.2% consisting of trace amounts of other elements. Due to mass segregation, the core region is estimated to be primarily composed of iron, 88.8%, with smaller amounts of nickel, sulfur, and less than 1% trace elements, which originates the magnetic field of Earth. The crust is mainly composed of lighter elements, silicium, aluminum, calcium, magnesium, sodium, potassium, titanium, phosphorus, and manganese, but also a little bit of iron. The atmosphere is today composed of nitrogen, oxygen, argon, but argon just under 1%. Carbon dioxide represents 0.041%, and the rest is trace elements. Due to its composition, internal heat is created by the fission of radioactive elements potassium-40, uranium-238, and thorium-232. This heat combined with gravity explains the gradient of temperature from surface to the core. The core temperature is estimated to be around 6,000 degrees centigrade or 11,000 degrees Fahrenheit. The planet receives energy from the sun. Outside the atmosphere, this energy represents 1,350 watt per square meter. 30% of this energy coming from light is reflected into space. The rest is partly absorbed by the surface and re-emitted and heats the atmosphere. Greenhouse gases are key in the heating of the atmosphere. We will talk about them in an episode to come, the one about the climate. The radiations are also captured in the visible light by plants as a source of energy for photosynthesis. One of the characteristics of our planet is to host life. Life, as it developed, has a big impact on the atmosphere, as said, by transforming CO2 into O2, so carbon dioxide into oxygen. The composition of the atmosphere is the direct result of life. Evolution has led to humans which exploit the resources of the planet. The upper crust has been largely transformed. Agriculture has changed the landscapes from forests to field and pastures. The need for more agricultural land is still leading the deforestation in equatorial areas. Human activity has a large impact on the planet, its atmosphere, the seas, the ground, etc. And this is exactly where the topic sustainability begins. As we know, SAP's vision is to make the world run better. For more than 50 years, SAP have been helping companies to operate better, to manage themselves better. In this third season of Back to Basics videos, we will see and review how to go about it and which solutions from the business technology platform, that is the platform SAP partners and customers use to create solutions, how these solutions from the business technology platform can help to understand sustainability in the company. Now that we know a little bit more about the planet Earth, I will see you next time, episode 2, which will be all about energy. Energies, probably. See you soon.